We present a system for automatically extracting layers from 2D multi-layered images or 3D datasets, and creating interactive and compact image-based representations of these 3D datasets. We use multi-layer extraction on a small set of input images, and new images are synthesized with any combination of layers. We now demonstrate user interaction with explorable images using the same flexibility provided by a transfer function editor. Users can interactively modify the opacity and color of any layer and apply cutaways in image space without re-rendering. This example demonstrates the reconstruction of 7 layers from only 3 input images for the supernova dataset. The rightmost image is an alpha mask we applied to several outer layers to reveal internal structures in the data. We begin with a default color map and modify the color and opacity of each individual layer. We demonstrate that the user can modify the opacity and color mapping with the flexibility of a transfer function editor used for volume rendering. All the interactions are performed entirely in image space. The opacity of a layer can be decreased and increased. The layer can be completely removed by setting its opacity to 0. We can also apply alpha masks to individual layers, which lets us achieve striking effects. Here we apply a radial alpha mask to several outer layers to reveal the inner structures that were previously occluded. This is done without re-rendering. We now demonstrate the reconstruction of 7 layers from 3 images for a different view of the supernova dataset and the application of a volumetric cutaway. We now modify the color and opacity of individual layers. Again, all this exploration is possible in image space from a very small set of input images. We apply a volumetric cutaway to 3 outer layers to reveal the inside features. The slider can be used to control the opacity of the mask. We now demonstrate the reconstruction of 7 layers from only 4 input images for the turbulent flow dataset. We change the color and opacity of each individual layer. Note how the opacity of a layer can range from completely transparent to completely opaque. Now we show the reconstruction of 5 layers from only 3 input images for the lifted flame dataset and simulate the application of 2 cutaway planes. We modify the color and opacity of each layer, demonstrating how layers can be made completely opaque or completely transparent. All explorations are performed in image space without re-rendering. We simulate the application of cutaway planes for 2 layers at a time, revealing occluded inner structures. Our method provides a useful representation for caching, remote visualization, rendering on low-end devices, and turning plain volume rendering images into fully explorable media.